I don't think it'd be a virtual talk if there wasn't some sort of difficulty at the beginning. So thank you all for tuning in to this talk on the legacy of lead in the soils of Durham. My name is Anna Wade, and I'm presenting this work alongside my PhD advisor, Dan Richter, as well as some amazing graduate and undergraduate students. And so I'd like to start by introducing our team of people. We're based in the Nicholas School of the Environment at Duke University. And we also want to say thanks to Duke University Basque Connections program, which granted us funding for this work in 2018. And I'd also like to say a special thanks to our colleagues who've provided very valuable support and feedback on this research, as well as North Carolina Lead and Healthy Homes Task Force, who've been working on reducing lead exposure for years, and they've really been an inspiration for our research. So I'd like to start out with a story. In April 2019, a structure fire broke out in the famous Notre Dame Cathedral. It's shown in this video. And it destroyed the cathedral's roof and spire. And the New York Times later reported about an unforeseen environmental consequence, that flames had engulfed 460 tons of lead when Notre Dame's roof and spire burned, scattering dangerous dust onto the streets and parks of Paris. Now, why would this release of lead into the environment be such a problem? Well, we'll come back to this in a bit, but for now, I want you to keep that number, 460 tons of lead burned, in mind. So here's a roadmap for this evening's talk. Again, thank you for tuning in. So first, a brief overview of the rise and fall of leaded gasoline and lead-based paint. Second, soil lead contamination in cities. So how soils are a giant reservoir for lead. Third, our Durham-based soil study. I'll introduce that and talk about our results. And then finally, I'll briefly touch on what we can do to have clean and safe soil. And before I begin, a brief disclaimer: I am a soil scientist, a soil biogeochemist, and I'm not a public health expert. But thankfully, there are a lot of public health experts who know a lot about lead exposure, and I'll mention some of those resources at the end. So I'd like to go back in time to 1980, when a scientist named Claire Patterson, shown in the bottom right, was pioneering techniques to measure lead levels in Arctic ice core samples. And he discovered that leaded gasoline had led to a significant rise in atmospheric levels of lead, threatening public health. In a 1980 report to the National Academy of Science, Patterson wrote, "Sometime in the near future, it will probably be shown that older urban areas of the United States have been rendered more or less uninhabitable by the millions of tons of poisonous industrial lead residues that have accumulated in cities during the past century." So what is he talking about? And can we disprove or confirm this prediction? Well, to understand Patterson, we need to understand the history of leaded gasoline in the United States. So many gas pumps today still say unleaded gasoline. And this is actually a reference back to when leaded gasoline was sold in the United States. So in 1925, the US Public Health Service concluded that there is no danger posed by adding lead to gasoline. So subsequently, the federal government allowed the sale of leaded gasoline. So lead was used, it was used as an anti-knock additive. So it basically increased engine performance in cars. So subsequently, the use of leaded gasoline rapidly rose, so that by the 1970s, the annual consumption of leaded gasoline exceeded 270,000 metric tons in the United States and 375,000 worldwide. Then in 1970, the Clean Air Act was passed in response to strong public pressure to clean up the nation's air and water. And so this act required a 90% reduction in gasoline emissions, and these reductions would require the use of catalytic converters, which they could not use leaded gasoline because it would clog them up. So in response to that, the EPA began something called the Lead Phase Down Program to reduce the content of lead in gasoline over time, and it required a 91% drop in lead by 1986. This resulted in a sharp decline over the 1970s and 1980s, so that by 1995, leaded fuel comprised less than 1% of gasoline sales in the United States. And today, only 6 countries use leaded gasoline worldwide. So in total, during this time, over 7 million tons of lead were burned as lead additives during the 1900s, with the bulk of this occurring between 1950 and 1980, with peak usage in 1973. And this lead phase down program had quite an immediate effect on public health. So the graph on the left shows that blood lead levels in the average American, so both adults and children, dropped by 37% from 1976 to 1980. And this was largely due to drops in the level of fine lead particles in the air, which declined in sync with gasoline lead levels. And together, these results, blood lead levels dropping, air lead levels dropping, really helped the EPA build a case against gasoline companies that were at the time suing the EPA for these lead restrictions. So where did the lead from leaded gasoline go after it was emitted as exhaust? Well, unlike water, which can evaporate and turn into a gas like shown, lead remains a solid, and like very fine dust, it eventually settles on the ground like dust after this dust storm. So the majority of this leaded gasoline dust settled out in urban areas. This map shows how large cities like Los Angeles and New York had the largest amount of lead deposited. But we also know that smaller urban areas experienced this phenomenon as well, including Raleigh, Durham, and Charlotte. Now, another major use of lead was lead-based paint. So lead-based paint was promoted heavily during the 1920s by the National Lead Company and the Lead Industries Association. And I found these flyers online. They're pretty ridiculous now, but so on the left, there were Dutch boy paint ads in the 1920s that promoted the long-lasting properties of lead-based paint, even with a child, to emphasize that it was safe to use, while flyers featuring minors on the right promoted the durability of lead-based paint, including phrases such as, "It's a pretty safe rule to follow. The higher the lead content, the better the paint." So in total, approximately the same amount of lead was used in commercial production of lead-based paint as was used in leaded gasoline, as this diagram shows. Although, as you can see, the use of paint began earlier in the 1800s and peaked earlier, around the 1920s. So I'm going to walk you through a brief timeline of lead-based paint usage in the United States. So its use began sometime in the 1800s. We don't know exactly when, but we know it reached its peak in the 1920s during the housing boom after World War I. And then it wasn't until 1951 that the first restriction in the country happened, when Baltimore banned the use of lead-based interior paint. As new information was coming out during this time that lead-based paint was toxic. But countrywide restrictions were not put in place until the 1970s. So in 1978, lead was banned for use in all residential paint across the country. And today, regulations actually vary tremendously by country, which is another topic of discussion, but for instance, India has not banned lead-based paint. So in the United States, the limits on lead in paint became much stricter after the 1970s. And that's why lead exposure risk is higher in older buildings. So before 1955, the percentage of lead in paint was up to 50%. So that means paint being put onto the walls of residential homes had incredibly high levels of lead. But in 1971, the US government restricted lead content in paint to 1%. And then they further lowered it to 0.06% in 1977. And today, it's at the limit on lead in paint is 0.009%. And these limits, this decline in lead in paint over time, show why it's federal law that tenants or buyers of buildings built before 1978 must be notified of any lead-based paint risk. So if you've rented an older house, you might have been handed something, hopefully something by your landlord about the risk of lead-based paint. And this graph really shows why there's higher risk in older buildings. And today, the highest risk comes from this old paint that still peels and cracks, and it generates paint chips and dust with high lead levels. So to summarize, leaded gasoline resulted in 7 million tons of lead from the 1920s to the 1980s being released into the environment in the United States, primarily as fine dust particles, so they are very invisible. They underwent long-range transport, so they could travel a couple blocks, a couple miles, but primarily the deposition was concentrated in urban areas. And then lead-based paint, there were 6 million tons of lead used in lead-based paint over about the course of a century. And today, we can see it as fine dust or paint chips. These are both visible and invisible. And they're primarily localized to within and around the home. So I want to circle back to the Notre Dame fire, and based on that calculation of 3 million tons of lead total from gasoline and paint, we can deduce that the amount of lead put into the environment from gasoline and paint during that time would be equivalent to almost 29,000 Notre Dame fires. So that's a huge amount of lead being released into cities across the United States. But why do we care? Well, lead exposure is a critical health issue, especially for children who are developing. They have smaller body mass, high hand-to-mouth activities. They're always touching things and putting their hands in things. And infants and young children, they're especially sensitive to even low levels of lead, and that can contribute to behavioral problems, learning deficits, and lowered IQ. So this graph shows how the CDC keeps lowering what counts as an acceptable blood lead level in children. So today, for instance, on the far right, if a child's blood lead level is higher than 5 micrograms per deciliter, an intervention would be needed to lower that child's blood lead levels and ensure that child does not experience neurological damage. But more recently, the CDC has stated that really there's no threshold that's been identified for the harmful effects of lead. So this is a very dangerous issue, and health effects of lead can occur at very low levels of exposure. So I've just said a lot. So before I go on, I would like to pause and ask if there are any questions.
We're riveted. Why don't you go on?
Thanks, Dan. Okay, well, I will go on. So why do we care about this issue today? Well, that's because lead from gasoline and paint remains in urban soils today. And as a result, the amounts of lead in some soils remain elevated. So one of the first studies on soil lead concentrations is shown on the right. There's a wonderful scientist named Howard Milkey at Tulane University who collected over 5,000 soil samples in the city of New Orleans. And the black dots show the sample locations. And he concluded that soils were an important source of legacy lead. So he found that samples from the river sediments had natural soil lead levels, and they range from 5 to 30 parts per million. So ppm stands for parts per million, shown here, and it's a unit used for really small percentages. So it's easier to say 5 parts per million than 0.005%. These values in the river sediments, these are what you'd expect if you went into a pristine park or somewhere very remote where there is no contamination. Samples from the city, however, range from 500 to over 1,000 parts per million lead. And these exceeded the EPA limits for contaminated soil, which are 400 parts per million for play areas and 1,200 for non-play areas. And in 2017, in reference to these findings of high lead in the soil, Milkey described his results in what I think is a really interesting way. He said, "You wander around and you don't realize that there's a mountain of lead downtown," in reference to this map. So why do soil lead levels remain high? Well, this is just a fun fact for you guys that I didn't know until very recently, that Pb, that stands for the element lead, which of course we know that, but it comes from the Latin word plebum, which is the same origin as plumbing and plumbers. And why is that? Well, that's because the Romans used lead in their pipes, hence the elemental symbol Pb. But back to the question. So why do soil lead levels remain high? So lead strongly absorbs to the soil and it persists for a long amount of time. So its half-life, which is the rate at which an element decays. So it's a lot longer than the age of the universe. So what that means is that this lead is not really going away. Lead also does not leach and it is not taken up by the plants. And it really only moves through physical mixing. So once the lead is deposited in the soil, it tends to stay there. And it comes from this rock galena, which comprises only a small fraction of the Earth's crust. So it's pretty impressive that it's so widespread in the environment today. And we also have to consider how might soil lead levels change over time. So believe it or not, half a century has passed since the 1970s when lead that was being deposited in red from the Volkswagen Beetle and off of houses. So some of that lead that was deposited then is probably still there today, but some of it might be gone. And that's because there's soil processes that occur over time and they redistribute, erode, and bury lead. Here again, I'm showing the lead particles in red. And so natural soil processes in the top, these include processes like erosion or organic matter. So organic matter accumulation, just think of leaves and grass, and this buries the lead, as well as human-driven soil processes like composting, which again buries the lead, construction, which oftentimes scrapes off the topsoil. And because every city is so different, I'd like to argue that every city needs a soil lead map, because we measure air, we measure water, and why not soil? It's not that hard. The good news is that more and more cities are measuring soil lead. So Baltimore was the first one in 1983. And since then, there have been studies in cities such as New Orleans and Sacramento, Detroit, and Los Angeles. So the year shows the date that the study was conducted. And by no means is this an exhaustive map. But what about North Carolina? So there have been no citywide soil lead studies yet to date, but there's certainly a need, especially in urban areas, such as where Raleigh-Durham is and Charlotte. So in the 1970s, there were sizable populations in these areas. So we can assume that there was significant use of leaded gasoline and lead-based paint. And it's been estimated that 5,000 to 8,000 tons of lead was deposited in these areas from 1950 to 1982. So we know that there was a lot of lead being put into the environment during that time. Also, from a public health perspective, there is a need to measure soil lead because children's blood lead levels still remain elevated. So in the 1990s, 5% of children tested in North Carolina had blood lead levels above the CDC threshold, which equated to 19,000 children. And in 2017, 1.3% of children on average in North Carolina had blood lead levels again above this new lower CDC threshold. And while there are certainly other sources for lead exposure, measuring soil lead helps us at least understand one of the most widespread sources. And that 1.3% in 2017, that was 1,700 children. So we want to get this number to zero in any way possible. So this brings us to our Durham study. So over the past year, we've sampled soils between I-85 to the north and Highway 147 to the south. And this represents the oldest part of the city when it was expanded in the 1920s. And it was previously identified as having the highest risk for lead contamination, especially along 147, which is older than I-85. Additionally, this area also has the highest density of old homes. So this map shows the age of single-family homes. So yellow, they were homes built before 1940. Green, those were homes built before 1978. So I want you to notice that the majority of these polygons are either yellow or green. So that means that the majority of these homes were built before 1978, which, if you remember, that was when the ban was put on lead-based paint. So these homes are at risk of having elevated soil lead due to paint chips and dust. So our questions were, how much soil lead is there along the streets and around houses in Durham? And then where is there the highest risk for soil lead exposure? And to do our study, we sampled streets in the right-of-way, so within 50 centimeters of the road. And I'll say urban soil sampling brought with it some surprises, such as this friendly dog that followed us around one day. And we sampled the soil, cleared it of grass and leaves, sampled the top 2 inches of soil because that was where the most of the lead we expected to find. And then we measured samples using an X-ray fluorescence spectrometer, which is this yellow device on the right. And it's very easy to lose a mouse. Okay, this device on the right shoots X-rays at the soil, essentially, and then it measures how those X-rays are reflected back. And then from this, we can tell how much lead there is. It's a phenomenal device. It's pretty incredible. So that was our methodology. And our sample sites consisted of samples along 25 miles of streets. And these blue dots show our sample locations. And we sampled along both major thoroughfares, such as Roxborough, as well as more local streets that we expected to have less traffic. So these points were, this is where the points I just showed you were, so these points are right here. We also sampled, so this is the city center, our study area, but we also sampled 2 suburban developments in North Durham because we wanted to see what lead levels looked like in areas that were developed after leaded gasoline and lead-based paint were banned. So we sampled in a suburb that was built in the 2000s, and then a sample that was a suburb, I mean, that was built in the 2010s. We also sampled soils around 62 houses. So we sampled both the yard soil and then we sampled the foundation soil, which that just means the soil that was within 3 feet of the house foundation. So right against the house where we would expect a higher amount of paint chips and dust to accumulate. And finally, we sampled 10 parks because their locations shown here, because we wanted to see what soil lead levels were like in areas further removed from roads and houses. So further removed from those sources of lead. So before I share the results, I want to walk you through how to interpret them. So parts per million, ppm, again, is a percentage. So 50 ppm equals 0.05. Natural levels of soil. So if you were to go out in the middle of nowhere, no history of contamination, you would expect levels to range from anywhere from less than 10, really down to 2, up to 30. And now, so soil lead levels, really, the threshold for lead contamination depends on the country. So different countries, even states like California, have different soil screening levels. So, so these levels shown here, above these levels, cleanup would be recommended or required. So California, 80, Norway, 100, and Canada, cleanup would be recommended or required above 140 parts per million. And now the EPA guidelines are a little bit higher. So for play areas, so where children will be playing in the soil, the EPA limit is 400, and then for non-play areas, it's 1,200 parts per million. So this map shows the results for our street side soil samples. So bigger and darker circles, they have higher amounts of lead. So your eye is drawn to these bigger and darker circles. And what we found was that of the street side soil samples we took, less than, or about 4%, so 4% of the samples had natural levels of soil lead. And then 40% of the samples fell under 100 parts per million. So say in Norway, those any samples above 100 would, be recommended cleanup or required cleanup. So 40% of our samples fell under 100. And then 55%, so the majority of them fell above 100, but less than 400. So they fell above the soil screening levels, say for Norway, but for EPA guidelines based on those, these would not be considered contaminated. And finally, 5% of our samples along streets fell above the EPA limit. And these samples were primarily near current or abandoned, like former gas station locations, or along more highly trafficked areas such as around a mall, or along a major thoroughfare such as Roxborough Road. So those areas often had higher lead concentrations. Now, for house soil lead samples, newer houses had lower levels of lead around the foundation. So these graphs show foundation soil samples on the left. So remember, these are samples within 3 feet of the house. And then the yard soil samples on the right. And both of these are plotted against house age, so the year the house was built, and then the soil lead levels. And this is on a log scale, so I want you to note those units. But as you can see, the newer houses have lower levels of lead in their soils, particularly around the foundation. Now here, I took the average level of lead in the foundation and yard soils for each house because we took multiple samples at each house, so just to simplify it. And what I want you to notice on these graphs is that this slope is steeper on the left. So this means that house age has a bigger impact on foundation soil lead levels than on yard soils. And that's likely because of lead-based paint chips and dust that have accumulated close to the house in these older houses, and that source of lead from the paint has not accumulated as much in the yards. So for the foundation samples, looking at it more in depth, of the houses we sampled, 30 of them had foundation soils that exceeded the EPA limit for lead. And all of these houses were built prior to 1978. And then over 50% of the homes built prior to 1978 had contaminated soil. So that's another way to look at it. Now for yard soils had lower levels of lead than foundation soils. And there's less of a difference between pre-1978 and post-1978 homes. And you can see this because the slope of the line is closer to 0. And this is likely because lead-based paint, again, didn't accumulate to yards to the same extent as around the house foundation. So now comparing soil lead across types. So we have street side in red, suburb, the new suburb in gray, and the foundation soil samples in purple, and then the yard samples in this teal color. And this is a density distribution graph, which shows the density. I'm getting some chat, so if anyone, I'll respond to questions at the end. But a density distribution graph shows the distribution of data. So it shows where the frequency of occurrence is highest. So for instance, the suburb samples shown here have a high likelihood of being between 10 and 30 parts per million. Whereas the street side samples, notice that there's a wider range of values shown here, and it has a less pronounced peak around 200 parts per million. And this is on a log scale. Okay, so comparing soil lead across the types. So here I've shaded in where we would expect the natural levels of soil lead to occur. And so we can see that the new suburban developments, they had natural levels of soil lead. So that's good, that's what we would expect. Now if we add the lines to show those different regulatory limits on soil lead I mentioned earlier, so the lower screening level in California and Norway at 100, and then the EPA limit for soil and play areas at 400, we can see that both street side and house soil samples, they fall above this this natural range in soil lead. So they show indication of contamination. So from both paint and gasoline. And furthermore, the foundation soil samples, they were most likely to be above the EPA limit of 400 parts per million. So finally, soil lead in parks. So the soil lead averaged 70 parts per million. It ranged from 15 to 189 parts per million in these parks. So the takeaway here is that they had lower levels of soil lead. The highest was this one in yellow. It was along a busier road, and it was actually the smallest park we sampled too, so it was closest to the roads. But overall, the parks had a lower risk for soil lead exposure. So if we revisit Patterson's quote, older urban areas of the United States have been rendered more or less uninhabitable. I think our results suggest that overall soil lead levels in Durham are declining, but hot spots remain, especially around houses with lead-based paint, which again makes it essential that cities start measuring soils around homes, along streets, etc. So I'd like to end with a slide about what we can do and how we can promote a clean and safe soil in our cities. So first, check your home, especially if your home was built before 1978. Be careful around the foundation and keep children away from flaking paint. And if you're gardening, it's especially wise to build some sort of raised bed. Second, we can target high-risk areas such as daycares. We can measure them for contaminated soil, and if the soils have elevated levels of lead, cover that soil with clean soil and cheap geotextile fabric, just to build a barrier between the children and that contaminated soil. We can also measure soil. So again, every city needs a soil lead map. It does not have to be, well, it does, monitoring lead levels is not enough. But I think it's within reach to subset different cities, et cetera, and to put more effort into this. And finally, tying it back to TLC, we can support and protect parks and open spaces because these areas are likely to have lower soil lead levels, and it's also important to protect these parks and spaces for future enjoyment, especially right now as we're trying to social distance and also get outside. So with that, I'd like to also add some additional resources, including resources from the EPA about lead, the CDC. The UN has an interesting web page about eliminating lead-based paint worldwide, and then some other links. And then just want to say thanks for tuning in, and if you're interested in learning more about this topic and more of my work on soils, I have a public defense. I'm defending my PhD in next month, Friday, June 19th. Email me for the link. My email is on the screen. And with that, hopefully there won't be any more technical glitches. And I'd like to see if there are any questions.
Yeah, so thanks, Anna, and feel free to ask any questions in the chat box. We do have a few questions. The first one was, what do you do once these soil lead maps are constructed? Are there any policies or responses that could be taken?
That's a great question. So we're at this data is hot off the press, and our plan is to talk and present it to the city. We also are going to publish a peer-reviewed paper about this, and I need to go back. There we go. And I think just getting information out is the first step. Getting information to homeowners, to any resident about the risk of lead exposure in the soil, I think is the first step. So we would love to get the word out to Durham in a variety of ways. We haven't discussed how we're going to do that yet, but this talk, it was, you know, one way. So we want to start engaging with the residents in the city and also present the results in a tangible way to the city council and elected officials.
Great. So the next question is, are there any testing around schools?
There are no testing around schools in Durham, to my knowledge, but there have been tests around schools in other cities. I think in Detroit and Baltimore, and I think that would be a great, you know, that would be a high risk area. So I think that's a great idea to not just think about daycare centers, but to think about schools as well. And because that, you know, those are areas with bare dirt that have children playing in them. So I think that's a really important next step.
So the next question was that someone read that plants could uptake lead and could be consumed. Is that incorrect?
I have not encountered any literature that talks about plants taking up significant amounts of lead. I will say, and I didn't touch on this, but there can be lead exposure through toys, spices, and makeup. So spices can be a source for lead exposure, especially imported spices. And so, you know, that's a part of the plant. So I think that that's probably maybe where perhaps where maybe that reading came from. But I do know that spices can be a source of lead, but I don't think I'm not sure about maybe leafy greens or anything like that being able to take it up in significant amounts.
Okay.
I will add briefly that there was a study in New York City. So they did an urban gardening study, and I think they found that there was a higher risk for lead exposure just based on the soil on the plant. So if the plant wasn't adequately washed and cleaned before it was consumed, then there was a greater risk from that than eating the plant itself, if that makes sense. And for gardening, the EPA does have they do caution to be very aware of soil lead levels, especially if you're gardening in a urban environment, which is why it's a good idea to have raised beds or something like that.
So the next question was from a teacher at a local high school. They wanted to know, do we have any cities in the area that have soil lead maps that students could access? Any ways for students to investigate lead levels in their local soils?
Any ways for students to investigate lead? Well, to my knowledge, and we have a colleague in Greensboro, he's been doing some soil lead measurements, but there's not yet to date been a map of soil lead values in North Carolina. But we do want to make this data public and usable, and our hope is to, that other cities would do this as well. So, but I think if a student is interested in looking perhaps at other publicly available data for soil lead levels in other cities, Howard Milkey, who I referenced earlier, the New Orleans, they have a lot of data about the soil lead there. Also Detroit. So there's a increasingly rich literature of cities that have collected soil lead measurements as well. It just may not be in North Carolina. But our hope is that there'd be more studies to come. So it's a great question.
Okay, and the next question is, did you look at markers of bioavailability of lead or just the total lead in the soil?
Ah, I knew someone would ask this. This is total soil lead. So the X-ray fluorescence spectrometer measures total. And we did, so the relationship between total and bioavailable is a pretty good linear relationship. And we do have some data on the bioavailable amount. But for our purposes, and for the EPA's purpose, their 400 parts per million is on total soil lead. So for our purposes, we have not focused too much on the bioavailable fraction, because also that can be an operational definition depending on the amount of strength of the acid or whatever you use to extract the lead from the soil. So that definition of bioavailability can shift as well. So, but that's a great question. We've just been primarily focused on the total amount.
The next question is, are soil lead levels dependent on elevation of housing or parking areas or park areas? And do they change if they're near moving water, such as rivers?
Let me see if I can go back. Okay. Can slowly click back. That's our next step. So whoever asked that question is reading my mind. But this map here, so is a hill, it's a hillshade, so it just shows some slight topographic variations. But we did sample, so the parks that I mentioned, 5 of those parks were in upland-like environments, so sitting high in the landscape. And then 5 of the parks we sampled in floodplains, so these in lower elevations, because we wanted to see the difference in soil lead, because our thought is that one reason the soil lead levels are declining over time is that the soil is eroding, and so there's that higher lead content soil is eroding and and accumulating in these lower elevation areas. And so we haven't looked at that on a point by point basis, but right now with this map, for instance, this is the street side soil lead levels, and these smaller yellow dots, those are the ones that had really low levels of lead. So what we want to do is revisit these sites and look at the surrounding environment to see if there's indication of a lot of erosion or some sort of elevational change that might be occurring. But also with some of these points, so this is a street called Alston Avenue, and this whole area where my mouse is currently being heavily under construction, and they've been bringing in a lot of new soil, new fill, and so that's why the levels of lead are so low here, and we weren't able to collect them here because that was an active construction site. But then when you go up further along the street, this part of the street isn't under construction, so it had those higher lead levels. And so I think there's an impact of elevation, and then there's also this impact of ongoing construction kind of turning over and also having an impact.
Okay, and the next question was that someone read that there's a new federal initiative to address the lead issue. Will this address soil and your work?
I'm not sure. I don't know what federal initiative that is, but I will definitely look that up. I've heard that the EPA is considering lowering the limit on lead in the soil from 400 to 200, and so I'm not sure if that's playing into that federal initiative, but our hope is definitely that soils would be considered more prominent of a source for lead exposure than they have in the past, because in the past, soils have not always been acknowledged or considered as heavily as, again, a source. So I'm afraid I don't know what that initiative exactly is, but our hope is that they would take into consideration the growing body of research around this issue in cities across the US. And I hope that they continue to lower the lead limit. I think that it's telling that California and Norway and other countries, Canada, they all have levels that are far below 400, and certainly far below 1200. And I'll just finally add, these levels haven't, 400 and 1200 parts per million, I don't believe they've adjusted those levels in quite some time. I think maybe the 2000. So I think it's probably time to revisit those guidelines.
So we have two more questions that will definitely bring us at time. The next question was, in order to have more maps created for cities, would it be feasible for non-scientist citizens to collect samples and mail them into the lab doing the study so that more samples could be collected from more places?
That would be great. Yeah, that sounds, I think this is a great opportunity for, one thing that I've really enjoyed as a PhD student who spent years in Durham is being able to do a study in my own city and feel like I have this connection to the city and the people. And so I think some sort of collaboration with, the scientists, the researchers, and the citizens, and I think that would be a great next step. I don't know of, I think there have been 2 studies or so, a handful of studies that have done something similar. I think in New York, I think again in probably New Orleans, they've just done a great job overall, and then maybe in Detroit. So that has happened in the past. So that would be great to have in North Carolina as well.
And the last question is, does this point to any environmental justice issues?
Yes. Well, yes, I would definitely say yes. One thing that I didn't touch on was that, I think, so different the amount of lead in the soil is one thing. And then the amount of, let's say, I'm trying to think of I'll leave it here. But if you had one house that had a lot of grass and a lot of trees and a lot of shrubs, that soil would essentially be covered up and not susceptible to, a child would be less susceptible to being exposed. And then if you had a house that had a lot of bare dirt, that, a child playing in that would have a higher likelihood of exposure. So I think, and that can be tied to, the amount of resources people have to put into the properties that they inhabit. So if someone, rents a place and their landlord does not you know, doesn't have a good handle on the lead limit or lead levels in the paint, you know, then a child can be susceptible to exposure. And also if, you know, a family doesn't have the resources to, and the time to, you know, take, you know, the property, manage the property and just grow grass. All my grass is dead. So, but, you know, then that's another source of exposure. So I think environmental justice definitely plays into it. And we haven't explored that in this study, but the let me see if I can go back. So there was Mari Lee Miranda in 2000. Here we go, 2002. Miranda, 2002. This was a paper that talked about the risk for lead contamination, and it tied into some socioeconomic variables as well. So I would direct you to that paper, and you can email me if you have further questions.
Yep, so as Anna said, if you have any questions, feel free to email me or her. But I'd like to thank you so much for presenting today, Anna. I really appreciate your flexibility to switch presentation formats and just your willingness to present. And to all viewers, thank you again for tuning in. Please view the TLC's events page for more ways to remotely get involved in the future. Stay safe and good night, everyone.
Thank you so much, Diamond, and thank you all for tuning in. I really, those were great questions. So if you have, again, yeah, like she said, if you have additional ones, please don't hesitate to email me.